I'm Professor C.Athey from Stanford GSB, and I'm currently Chief Economist at the Antitrust Division at the DOJ. And to do the table setting for the rest of the day, we're really fortunate to have two of the leading lights in AI from computer science. And so we'll be connecting the technology and the science to the competition issues we're talking about today. And to start off with, we are so fortunate to have Percy Liang here, who's a professor of computer science, and all of the bios, extended bios for our speakers are on the website. So as a star AI professor at Stanford and one of the leading lights of natural language processing, you were perfectly positioned to lead us as we transitioned into this latest evolution of AI. And indeed, you were ahead of the game. We were actually working together at the Stanford Institute for Human-Centered Artificial Intelligence a few years ago, and you had the foresight to propose and start the Center for Research on Foundation Models in 2021, before the rest of the world was quite so aware of what this was all going to look like. Can you talk about your vision for the center and why you founded it and how it's going?
Yeah. Thanks for having me, Susan. So 2021, basically prehistory in AI terms. For many, ChatGPT 2022, December, was the sort of the turning point. For me, it was May 2020. That's when OpenAI released their GPT-3 model. And that model was a huge model, an order of magnitude larger than before, and it demonstrated to me that this technology and this mindset of training larger and larger models was going to have a huge impact on society. And at that time, I went around, talked to many folks at HAI, and say, hey, we got to pay attention to this. Fortunately, many people were also compassionate and agreed. So we've founded the Center for Research on Foundation Models. Some people thought I was crazy, but that's fine.
Turned out you were right.
Maybe so crazy. Both can be true. But it was surprising. ChatGPT, I think, really demonstrated that this was something to pay attention to, and it did come faster than I thought. But so what is foundation models about? So the idea of a foundation model is that someone can take a large amount of data at scale, usually scraped from the internet, and throw a huge amount of computation power at it. And this one recipe can produce a single model that is capable of demonstrating a large range of tasks, not just a high-end generation, but also ability to solve many tasks. So for the first time, we have more of these generalist agents that people had aspired to for decades. I've been an AI researcher for a few decades, and this moment is very special. So it's somehow the idea that you can take capital and put it in and sort of predictably get more and more capabilities. That was a sort of a mindset change. And I want to also stress that foundation models isn't just about ChatGPT or language models. It's a much more general idea that any time in any domain where you have a huge amount of data, whether it be vision, videos, time series, retail data, computational biology, astronomy, all these areas we're seeing being transformed because of this kind of remarkably simple idea where you have a transformer architecture plus a gradient descent plus GPUs allows you to, in any domain, give you sort of remarkable properties.
Great, thank you so much. And so what does the center actually want to do? What are your goals in this and hopes and how you can contribute to the conversation about them?
Yeah, so why do we create this center? So one thing that we were reacting to was that at that time, since 2020, and you see it kind of progress more in this direction, is that the level of transparency and openness that we see in AI has diminished. Right. In the 2010s, when the deep learning revolution was going strong, there was a culture of researchers sharing data, code, models openly, and various companies would be able to, startups would be able to leverage this. And I think a lot of the innovation came from this openness. But what has happened over the last 3 years is kind of as capabilities go up, openness goes down. So from the idea that initially the model weights, which is something hopefully we'll get to a little bit later, are no longer available, to the stop of publications and gating of access. And this, I think, from an academic researcher perspective, was quite concerning. And not only from a researcher's perspective, where maybe academia could no longer engage with this important technology, but also from a societal aspect, if we have this hugely important technology which we don't understand and is locked away behind, guarded closely, then we might be in a bad situation. So the center was created with a mission of making foundation models more accessible, more transparent for the world.
And so what are the what can you give some examples of how that transparency can be beneficial? What are some of the sort of use cases from the center that would be helpful from that transparency?
Yeah. So one of the key things that we're focused quite heavily on is benchmarking and evaluation. So we have these models that are being developed and released, and people are using them, but we have shockingly little rigorous evidence of what their actual capabilities and risks are. There are a bunch of demos and things are being deployed. And one thing that we've undertaken at the center is developing benchmarks. So we developed something called the Holistic Evaluation of Language Models 2 years ago, which we've been extending over time to look at all the different capabilities and risks of these models as best as we can, and to try to benchmark them and also make all these results publicly available for people to see. And one of the things that's difficult about benchmarking is that because these models are so general, how do you even test this? I don't like usually making analogies with humans, but it's kind of like humans, you're measuring the capabilities of a human being because they are so versatile. And so this is something that's very, very tricky, but I think we've made a lot of progress on this, covering many different tasks from question answering to summarization. Now we're looking at multimodal models for visual question answering and image generation, and looking at starting to look at other dialogue settings. So, and I think one thing that's important is having a third party, sort of neutral third party, that's doing these evaluations and committing to doing them across all of the foundation models that are frontier, and reporting the results in a standardized way.
Yeah, so is it fair to say that as of a couple of years ago, we didn't have a lot of science about how you would evaluate these types of models?
Yeah, so I think, and we still don't have a lot of science behind how to evaluate these models, but we have a little bit more now. I think the field of evaluation is just very much underdeveloped. I think in the history of machine learning, it used to be the case that you define the benchmarks, and these benchmarks would be very difficult. For example, ImageNet. When ImageNet was created, no vision system could really do anything respectable on it. And it was a sort of a North Star for many researchers to keep on working on ImageNet. And
so that was a database with a bunch of images and labels, and so you could just test out how your model worked against it, and there was a number, right? A number that said, okay, you beat the last benchmark, I'm the star of the AI conference this year.
Right. Yeah, and now I think it's sort of flipped where people are developing models, and now benchmarks are trying to catch up to capture what these models are doing. And on top of that, we're no longer interested in just the accuracy, but we're interested in things like bias and fairness and robustness and whether the models know what they don't know, and not to mention different types of risks. We heard about disinformation, but we heard about there's cyber risks, and all these different risks, and how do you measure them in a way that can inform businesses and policymakers.
And so do you think it's possible to do that science within like one research group in one place? Or do you think you need a larger community working on those problems?
I think you definitely need a larger community. And this is the way that academia works is that it's the community. We do a lot of work, but there's also good work happening at various places like University of Washington and many other universities where these data sets are created, and there's often benchmarks that are created that derive from these data sets, and then they're put together in different ways. And so a lot of the what we're missing is sort of methodological science for how to conduct benchmarks. I mean, just as a simple example, one of the things that ChatGPT can do is it can generate an essay or a summary, and this alone is a very deep problem. How do you evaluate something that's so complex? And of course, you run into cases where if it's on a topic that is very niche, then hiring human experts is going to be very expensive. So can you use language models themselves to evaluate? But then you don't trust the language models, so it's very interesting, I think, technically to see what you can do. And I think you can actually make some progress, even though it seems like you're kind of bootstrapping yourself.
Great. Well, but in general, so it sounds like your center is promoting the ability for lots of researchers to be able to contribute to this relatively nascent but important field. So could you talk us through, other than the open weights, what do you actually need to be able to do that kind of work? So if we want to have a large community of people contributing to this nascent science, which might take a long time to figure out, because as you mentioned, we'll probably still be developing new evaluation metrics in 10 years for new risks that have been identified. What do people need to be able to contribute to that, whether it's researchers or whether it's startups that are creating tools that can help other businesses deploy them safely? Like, what are the inputs to make that, to contribute to that?
Yeah, I think one thing I'll start by saying is in academia, we're meant to do fundamental research that moves the needle. And a lot of what we are missing right now is just compute. I think we can do a lot by taking existing models, benchmarking them. We can even, if we have open weights in the case of Llama 3 or Llama 2, we can inspect them. But I think there's no substitute for actually being able to train models. For example, we're developing different types of model architectures which are different from the transformer. And to demonstrate the value of those, we need to be able to train. And the resource differential between academia and industry is just multiple orders of magnitude. And I think it's unrealistic to expect them to be equal, but I think we, as a community, let's say, we need to invest more in computation so that we can at least be in playing the game.
So just to make sure I understand, so there's a couple of different kinds of research you can do. One is that you can take either a closed or an open model. For the closed, you have to pay for it, and then you can evaluate it using evaluation metrics. But then there's other research that you can do that kind of gets into the guts of it, that you could only do by training your own models, perhaps at smaller scale. And so could you talk about what's needed for the different types and what other inputs you might need for the second one?
Yeah, so for the first type, which is taking existing models and studying them, you need access. And for the most part, we do have access. I think it would be helpful to have deeper access. For example, with GPT-4, you can only get access to generations. You can't look inside what the model activations. And there's also, we don't have access to training data. So basic questions in machine learning, such as, is your test set in your training set? We have no ability to really know for sure. So there's some asterisks on the ability to do proper research there, but I would say it's in a much better state. And then I would say this latter category of models research, which involves intervening on the architecture or data, those require substantially more resources. And I think I think though you need enough resources to be able to train a large enough model to show that it can do something, right? So one of the phenomena that you see with these models is this emergent behavior. You need to be at a certain scale before you start seeing anything happening. Otherwise, it looks like nothing is working. Nothing is working. And I think the reason why this latter category is important but also under-resourced is that we talk about all these problems with these models, with AI, biases, hallucinations. People can jailbreak and get these models to behave in sort of unpredictable ways. I think these are really fundamental problems that these models have. And we're not going to be able to solve them just by patching things away. And this requires really addressing the fundamental core of like how the data interacts with the model and understanding that in a much deeper way, which unfortunately I think we don't have, the community doesn't have as much patience for this. But I'm sort of pushing for more resourcing so we can actually get to the bottom of things. And this is a long-term agenda to get to the bottom of things and hopefully develop a stronger foundation.
Great. Well, so one of the things, when you're doing the kind of fine-tuning or retrieval augmented generation or other types of uses of open models, even researchers or small startups need resources, they need compute. It's something that's been kind of amazing to me that it's sort of like the first time in my lifetime where you can put out a problem and Stanford master students can come out with something working in like 10 days, which it seems like kind of a miracle because everything you think is going to take 2 months and it takes 2 years. But here people are getting like working prototypes up very, very quickly all over campus and across the startup land. And there's a number of pieces that go into making that possible. So could you talk through what some of those pieces are for applications? And in particular, I think you recently co-founded a startup called Together.ai that kind of contributes some of the pieces people might use. But I'd love to hear about Together and what it does, and also what are the pieces that go into this that can make this spur innovation, across all of everyone? Yeah.
I mean, to start out with, I completely agree with you. It's sort of amazing what one can do, even in an afternoon with these models, because I think at some level, if you can write English, and then maybe another English, you can write a prompt, and you can sort of just state what you want this model to do, and if you're lucky enough, then it can actually do it. So as a result, this technology has really opened up the opportunity for many people who are not, don't have machine learning PhDs to be able to interact, which I think is wonderful. And we're seeing a lot of uptake in other areas like law and medicine where this normally wouldn't have happened. I will put a little bit asterisk is on the fact that there's a gap between getting a demo up where you look at it and it's like, wow, that's pretty cool, to an actual reliable product that you can ship to many, many people. So that last mile problem is still challenging. It might be a little bit easier, but don't get too excited.
And I think, let me just pause you there. That is a really excellent point, and that I've certainly heard that from a lot of people across the industry as well, because if you're going to, if you want to put something in front of your end customers, it's not enough that it mostly is right. It has to not say offensive things or do something that damages your reputation or creates risk. And so that's partly where your evaluation stuff comes in, that those tools are an important part. But so let's just talk though for the moment about getting to the demo step, even like what are the pieces, the inputs to that?
So from an application developer's perspective, right? So you have your problem. The thing that is probably the easiest to start is you take GPT-4 or Claude or Gemini or your favorite model and you prompt it just to get a sense of what it can do, right? And this is, I would really call this the prototyping phase, right? You're ideating and you can brainstorm while you're getting feedback from this actual system, which is, I think, sort of incredible kind of user interaction, new type of user interaction. And then I think there's but of course that's not enough, and it's also expensive to keep on using GPT-4. So one thing that's I think also important is that if you're a business and you have your own data and your own particular needs and businesses, you have to have generations that have a certain tone or style, or you don't want to have it say XYZ, then this is where fine-tuning comes in. You have to be able to specify. Fine-tuning basically says, I'm more opinionated about what my system wants to do, so I'm going to take some work to really flesh out, here are the cases where it should do X, and here's the cases where it should do Y, and then you fine-tune a model. And on top of that, you can connect these language models with different types of tools. So interacting with the world, and this is, you mentioned RAG, which stands for Retrieval Augmented Generation, the idea that you can take your internal documents and be able to look at them and have that influence your generation, or you can, if you have a database or different APIs inside your organization, you can query those as well and have the language model essentially as a sort of a driver that dispatches to different services and aggregates and then generates the result.
Let me summarize it at the end. So if you want to build something like that,
yeah.
what do you need to build it, and how does Together.ai fit in?
Yeah, so Together was founded 2 years ago on the premise that we wanted to build a platform that enabled developers to be able to use this technology in an easy and cost-effective and performant way as possible. So one of the services that we provide is simply inference. If you have, let's say, a Llama 3, an open model that you want to prompt and run, you can use Together, just like the way you would use GPT-4, but at a fraction of the price. You can also find.
It's kind of like a cloud computing solution for this that could host the model.
Yeah. So I think that's a good point. So one thing that people might maybe not quite realize is that there is the OpenAI and Googles of the world that have their ape services, and it's very convenient. And then on the other hand, you might hear these open weight models like Llama 3 or Mistral or Mixtral, where you get the weights, which is great for customization, but you might hear that, oh, okay, well, I have to host it myself and I have to deal with it. But that's not really true, because there's actually multiple services, including Together, that host these for you. So you really have the convenience of an OpenAI-like framework, but cheaper, and you get the benefits of transparency.
So you load up your data. So like when I see students doing here, they might load up their data. They then could fine tune one of those open models using the compute and sort of pay as you go. But then there are also software tools that people are using as well. So the students don't necessarily have to write all the code from scratch to do the fine tuning. Can you just say briefly like how that step works?
So if you want to fine tune, there's no code actually. You upload a file that has examples of input-output behaviors. This is an instruction, and this is the response. You put them in a file, you upload it, you click fine tune, and then you get your fine-tuned model, and then you can do inference on this just like you would be able to do inference on any other non-custom model.
Yeah, and so if we'd wanted to do something like that like 15 years ago, this would have been like, all the time writing the code for the stochastic gradient descent, for the debugging and everything else. But basically now, literally, you can produce your own version with your own documents by pushing a button. Yeah,
and I think it's even better than that, because 15 years ago, there were no foundation models. So you basically have to start from scratch. You would gather your data set, and then the problem is if you're starting from scratch, you need a fair amount of data. You might need thousands or tens of thousands of examples. to even get something that was interesting to play with. And that meant you needed to first go, get an annotation team, like hire annotators to create this data, and you spend, potentially months training the annotators, getting the data, and then you can train your model, and then you can see what it does. And then if it doesn't work, then you have to go back. But now, because of foundation models, you don't need that much data, because much of the common things about how English works or simple reasoning patterns, the model already knows about. So all you need to do is supply information about your specific needs. And so you might be able to get away with hundreds of examples. So the iteration cycles are much shorter. And then when you do prompting, it's often 5 examples or 0 examples. So I think that iteration cycle is much, much shorter.
Great. So actually, we're just running short on time, but I'm going to try to squeeze in my last favorite question. We have a lot of debates about the risks and benefits of open and closed. As an economist, I'm particularly interested in how you think about incremental risk of these open weight models. And could you just say briefly how you think about that?
Yeah, so one of the things that you might hear is that open weight, and I use the word open weight instead of open source deliberately to be more specific, is about these models is that, well, people can use them for harm. You can fine tune it, you can turn off the safety, and you can spread disinformation and so on. And I think it's really important to frame this conversation in terms of the whole picture, which is, first of all, that this model is a tool that is used to potentially generate some harmful content. But then this harmful content also needs to be disseminated, or in the case of, let's say, biorisk, you need to also synthesize the proteins. And so you need to think about the whole picture and where you want to gate. Another thing is that just because a model generates, let's say, how do I make a bomb? Okay, here's how you make a bomb. Doesn't mean that we should immediately just shut it off, because you can also find things like this on the internet. You can find a lot of things about how to make chemical or bioweapons on Wikipedia, and so there's a lot of other things. So one thing that we've been trying to get people to think about is the marginal risk of a particular technology with respect to what exists. And I think only then can you make a meaningful calculation of whether introducing this is going to, what is the risk there compared to the marginal benefits of having these models. And I think right now I don't see substantial evidence that the marginal risk is high. And OpenAI actually also did certain studies. The current models just aren't that impressive when it comes to enabling much a broader surface area of attacks. But this goes back to the point about evaluation. We need to much more rigorously evaluate the risks before we jump to conclusions and get out of our hells and speculate about what could potentially happen.
Well, you've made every intro economics professor's heart sing with marginal benefits and marginal costs, so I think that's a great place to close. Thank you so much for being here.
Thank you. That's great.
Thank you.